So now this is, we are continuing with alcohols. We can classify alcohols. Again, alcohol, what is an alcohol? Alcohol is a hydrocarbon or organic molecule in which you have the hydroxyl functional group. One of the hydrogens is replaced by the hydroxyl. So there are three categories of alcohols: primary, secondary, and tertiary alcohols. And by the number of hydrogens attached to the carbon, which is connected to the hydroxyl. So to differentiate or classify, we have to pick the carbon connected to the hydroxyl group. So this is the carbon in all three cases, which is connected to the hydroxyl group. So this carbon is connected to 2 hydrogens and a methyl. This is primary. 2 methyl and 1 hydrogen, secondary. All 3 methyls, tertiary. So the number of alkyl groups determines primary, secondary, tertiary. 1 alkyl, 2 alkyl, all 3 alkyl. Carbon can have 4 bonds. One is hydroxyl, making it alcohol, and the rest, the methyl groups, determine if it is a primary, secondary, or tertiary alcohol. So here, let's look at the carbon connected to the hydroxyl. It is connected to 2 methyl groups. This carbon connected to the hydroxyl is connected to 1 methyl group. This carbon connected to hydroxyl is connected to 3 methyl groups. So 1 methyl will be primary, 2 methyl will be secondary, 3 methyl will be tertiary. So that's how we determine the primary, secondary, tertiary alcohols. Again, alcohols are soluble in water. Alcohol is an organic compound. Organic compound mixing with water, a polar molecule, it is unique and rare. So we are trying to see what is the unique property of alcohol that it is able to mix well with water that's a polar molecule. We can take oil and water and try to mix. Oil is an organic compound. Water is a polar molecule. They do not mix well. But alcohol, being an organic molecule, mixes well with water, because alcohol is a polar molecule itself because of the presence of the OH functional group. Here you can see the OH functional group is polar. There are poles. There is a positive and a negative end in an oxygen molecule. Oxygen atom is a very electronegative atom. Water has oxygen, alcohol has oxygen. So because of its electronegative nature, what is electronegativity? Is the ability to attract electrons to itself. So the electrons surrounding the oxygen are attracted to the oxygen. Electrons are negative. So it creates a negative pole with the oxygen. You can see the negative pole with the oxygen. And the molecule changes into a polar molecule. So water and alcohol both are polar molecules, both have oxygen. So that makes them similar, and they are able to work with each other. They're miscible, they're dissolved in each other. So this is soluble in water, but as the carbon chain becomes longer and longer, the alcohols become less and less soluble in water. So the smaller the number of carbon atoms, you can see 1 carbon alcohol soluble, 2 carbon alcohol, 3 carbon alcohol soluble, 4 slightly, 5 insoluble. So as the number of carbon atoms increases, the solubility changes. Again, chemistry linked to daily life. We use ethanol, active ingredient of hand sanitizers, and this is approximately 60% volume by volume, 85% are highly flammable and produce transparent blue flame alcohols. They may also contain triclosan, which is, this is triclosan. What is triclosan? When you look at it, this is oxygen. This is a aromatic group. So this is an ether. Triclosan is an ether with the aromatic group on both sides of the oxygen connected to aromatic group. So this is an example of ether. Now phenols. Phenols are soluble in water. What is a phenol? Phenol is a benzene ring connected to hydroxyl group. So recognize a phenol. Soluble in water, explain why. We discussed smaller number of carbons in the alcohol soluble. As the chain increases, insoluble. So I will say this is soluble, this is insoluble. Because of the shorter, longer. Alcohols with long carbon chains are not soluble. Short chain alcohols form hydrogen bonds, which is again polar molecule. This is a polar molecule and water is polar, so they bond and they dissolve. So this is aldehydes and ketones. So can I just do this 10 minutes and then I'm done?
Okay.
Is that okay?
Yeah, that's fine. As long as we're just not running into another class.
Yeah, that's what it is. I'm okay. This may be probably 5, 7 minutes, 10 minutes max. And then picture of that, that would be in it for me. I'll put up another example. Or do I stop this here?
Depends on what you want to do.
Yeah, if there is a class, then I don't want to get into the class. Till 1:30, I have the class here.
I don't know if there's any more classes in here.
Yeah, so let me finish this, and then we'll take a shot of that, and then I'm done for today.
Okay.
And you will keep me posted for the next class.
Yes.
Aldehydes and ketones. So I'm still in chapter 12. We are discussing aldehydes and ketones. So let us see which page we are on here. We just finished alcohols, phenols, thiols, and ether. So I'm moving to aldehydes and ketones. It is page 409. So aldehydes and ketones are organic molecules which with the functional group, carbonyl functional group. So previously we discussed alcohols, phenols with the hydroxyl, thiols with the SH, ether with the oxygen alkyl aromatic link on both sides. Here we are looking at aldehydes and ketones, and you pick them out using the carbonyl functional group. This is the carbonyl functional group, CO. And again, I said this is because of the presence of oxygen, oxygen being electronegative. Oxygen has a great tendency to attract electrons. Electrons are negatively charged. So this oxygen tends to be electron dense, having all the negative charge around it. So it creates a negative environment there. So that's what I'm trying. Has a strong dipole with a partial positive on the carbon and a partial negative on the oxygen. Oxygen gains the negative charge because of the dense electrons around it. So this is called a polar bond. So an aldehyde is attached to carbon atom and at least one hydrogen. So a carbon oxygen, the carbonyl group in an aldehyde is at least attached to one hydrogen. And that's an aldehyde. When the carbonyl group has no hydrogen attached to it, it is a ketone. So there is a slight variation between the aldehyde and ketone. Both have the carbonyl functional group. Aldehyde has at least one hydrogen, and ketone does not. So it's attached to only alkyl groups. So you can write an aldehyde. Again, we said carbonyl group with at least one hydrogen. So you can say this, carbonyl, CHO, skeletal, CHO. Ketone, carbonyl attached to no hydrogens, two alkyl groups. So you can say CO. The CO, you don't have to show the bond. It's okay, say CO, or this is the skeletal structure of the carbonyl. An aldehyde, you replace the alkene E with the AL. Pentanol is an aldehyde. Pentanol is an alcohol. So 1 carbon, formaldehyde, acetaldehyde, these are common names. Okay? So you are calling aldehyde, propionaldehyde, acetaldehyde, formaldehyde. These are all common names with the IUPAC. Again, methane, methanol, ethane, ethanol. Here, carbonyl with hydrogen, carbonyl with hydrogen. All these are aldehydes. 1, 2, 3. Prop. 1, 2, 3, 4. Bute. So butanol, propanol. The carbonyl carbon is at the end of the chain. How do you name? You pick the longest carbon, replace the final letter of the alkane E with Al, and counting the carbonyl carbon as 1. So we are going to name, again, we are looking for functional group, if any. So I'm looking at this functional group, and this is a carbonyl functional group, aldehyde, carbonyl connected to hydrogen, aldehyde. So I'm going to call this is the first carbon. So I see a substituent, 1, 2, 3, 4, 5 carbon chain. So there is an aldehyde. Change E to Al, count the carbonyl carbon as 1. So pentanol, then we have to number the substituent. If I number carbon 1 with the carbonyl aldehyde group as 1, the methyl substituent takes number 2. So 2-methyl pentanol. So I count the longest carbon chain, number the aldehyde, give the number 1 carbon has the aldehyde group, 2 has the methyl. 2-methyl pentanol. So this is again chemistry linked to health. Vanilla. So this is vanillin is an aldehyde. So if you encounter vanilla extract, so it is an aldehyde, vanillin. Okay. Now we are naming ketones. You replace the E with the O-N-E. So propanone, butanone. Here I'm counting the carbons. Here I'm looking for the carbonyl, no hydrogens, so ketone. 1, 2, 3. Propanone. 1, 2, 3, 4. Butanone. 1, 2, 3, 4, 5. Pentanone. But here I am giving you which carbon has the carbonyl group, 3. So cyclohexane. So carbon, this will be the carbon 1. So 3 carbon has the methyl, 3-methyl cyclohexanone. So again, repeat of the naming guide. Name the longest carbon chain, replace E with O-N-E, number the carbon chain, giving the lowest number to the carbonyl group, any substituent on the carbon chain, starting with the lowest number to the carbonyl group. Here again, I'm looking at what do I have. I have to give the IUPAC name. So I'm looking at carbonyl group with no hydrogens. I'm looking at a ketone. So I'm going to replace the E in the alkane with O-N-E and number this carbon with the carbonyl group gets the lowest possible number. So how many carbons? Straight chain, 1, 2, 3, 4, 5. Pentane, pentanone. Excuse me. If this is carbon 1, 2, 2 pentanone, 3, 4 methyl. 4 methyl, 2 pentanone. 2 pentanone, 4 methyl, 2 pentanone. So aldehydes and ketones also form hydrogen bonds with water, are very soluble, fewer carbons, very soluble, but as the carbon chain increases, the solubility diminishes. Similar to alcohols we discussed, we can see methane, methanol, aldehyde, 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 ketone, aldehyde, ketone, aldehyde, ketone. So we see as the carbon chain increases, the solubility decreases. So acetone is used as a solvent in nail polish removers and cleaning fluids and paint. So this is a ketone. And formaldehyde, aldehyde is used as formalin to preserve biological specimens. So let us see, we have to identify these as aldehydes or ketones. I'm looking for a carbonyl group. I find one. No hydrogen to the carbonyl group, a ketone. Carbonyl group, hydrogen, at least one, aldehyde. Carbonyl group, at least one hydrogen, aldehyde. Carbonyl group, I see no hydrogen, ketone. So we identify these molecules, give the IUPAC name for these ketones. Name the longest carbon chain that contains the carbonyl group. 1, 2, 3, 4, 5, 6, hexanone. 1, 2, 3, 4, butanone. So this carbon gets the lowest possible number. So 2 hexanone, 2 butanone. And once you number, you can number the substituents. So this ketone has no substituents, but this has a substituent halogen, chlorine, chloro substituent on carbon 4. 4-chloro-2-butanone.